All right, 6.3. So we just got done doing add, subtract, and multiply with radical expressions. So now we're going to do binomial radical expressions, which is 3 words you may say, Mr. Westphal, what the crap? I don't know what those things mean, but breaking it down a little bit. Bi, remember, means two. So we're going to have two parts today, eventually. Right? Maybe not here in the beginning, but radical is just a check mark thing with an index. And then an expression is just something like this down here that doesn't have an equal sign, just like that. So our goal today is going to be add and subtract like radicals. All right, and so really this is no different than like adding and subtracting like terms. So if I had 5x plus x, you could hopefully tell me that that is 6x. So in this question we have, down here we have 5 of these things, crazy looking thing, third root of xy, plus 1 of them. And so we have 6 third roots of xy. Okay, so we essentially added those radical expressions together by just combining the coefficients just like we did in a question like this. All right, so that's what we're working on in section 6.3. So, like I said, 2x plus 6x, hopefully you know that that is just 8x. You just combine these coefficients. So here's 3 problems for you to jot down underneath the title of what we're doing today. Give them a shot by pausing the video. All right, both first ones are square root x, so we have 6 of them minus 2 of them, so we have 4 square roots of x. This one, don't forget there's like a 1 here, so we have 1 square root of 7 plus 3 square roots of 7, 4 square roots of 7. Okay, and then the last one, hopefully you got that. This one cannot be simplified. Okay, and the reason is they don't match. This would be sort of like 2x plus 3y. You can't actually add those together because the x and y parts don't match. So because these parts here don't match, one's a third root, one's a square root, you can't actually add them together. All right, and so this slide you don't really need to write down. It's just saying, again, as long as they match, they have the same index, the same radicand, you can add the coefficients. And same thing here, subtract them if it's to subtract between them. All right, here's, I guess, 3 more quick ones for you to pause the video and give them a shot. All right, so it looks kind of crazy, but these are both square roots of 5x, so you can do 3 minus 2, and you just get 1 square root of 5x. These ones, the radicals don't match again, so I'm just going to cannot be simplified. And then same thing down here, this is a third root and a fifth root, so even though the radicands match, it cannot be simplified. All right, so that's pretty much it for the basic questions, right? Like, they will get a little bit crazier, but hopefully like this one would just be 7x, you add 3x and 4x. Like this one, you just minus these parts because everything matches, so you get 2 fifth roots of 3x squared. All right, so hopefully those aren't too bad questions. All right, so I want to get to ones where they don't match. So if they don't match, I know we did cannot be simplified earlier on some of these, but sometimes there's a way to make them match. So here's an example of, these don't match. So technically we can't add them, but I want to see if you can figure out what to do on this. So pause the video and see if you can actually figure out how do you actually add these together. All right, so the trick is this root 12 can be split using our chart of perfect squares to 4, which is a perfect square, times 3. And then the 27 similarly splits to 9 is a perfect square and 3 is a non-perfect. So we end up having 3 times square root 4. Okay, and then 5 times square root of 9 is 3, right? So those become regular numbers. And then 3 times 2 is 6. 5 times 3 is 15. Right, and so now we have what we worked on previously where they match. Both are radical 3. So 6 plus 15 is 21. radical 3. Right, so the concept being, if they don't match, you should see, can I break them apart and get them to match, and then combine them that way. All right, so here's one for you to try. Right, you'll need your list of perfect squares. So if you don't have them written down, come back here to the slide and write them down. I'm just pausing awkwardly, waiting for you to try it. All right, here we go. So 490, I recognize that 49 is a perfect square. So I can do 49 and 10. And I know I'm okay here because there's no other perfect squares that divide 10. I was a little worried that there'd be a bigger number than 49, but the fact that there's no perfect squares in 10 makes me feel okay. Okay, 90, I'm going to do 9 in radical 10. 9 is a perfect square. And for 44 is a perfect square. So pull that off. Okay, and you can see why this is going to work because now you have all radical 10s, right? So basically just do your perfect square. Square root of 49 is 7. Square root of 9 is 3. And then square root of 4 is 2. Now that they're all radical 10s, I do 7 plus 3 is 10, minus 2 is 8 radical 10. All right, so one quick trick I want to talk about here too is if you pull off a radical 10 here first, there's a pretty good chance you can pull out radical 10s on the other ones, right? So I'm going to do another quick example here, but basically like on this first one, I know 4 is a perfect square. So when I break it off, there's a good chance that 7 is going to be the leftover part in these other ones, right? And if we actually do that, it'd be 25 and 7, and then it would be 9 and 7, right? And then you're good from there. It'd be 2 root 7 minus 5 root 7 plus 3 root 7. And so this would be, this is a little weird one actually. It'd become negative 3 root 7 plus 3 root 7. And those would cancel each other out, so you actually get 0. Pretty strange. If you really want to verify, you could type it in your calculator, figure it out. One more I do want you to try. This one's different because they're third roots. So I'm not going to tell you how to do it, but see if you can figure it out. All right, so how it works is we're going to use our third perfect third powers. So for 250, 216 doesn't work, but 125 does. So I'm going to break it into a third root, 125, and a third root of 2, plus, and then for 54, again, there's a good chance 2 is going to be the leftover part. So looks like if we divide by 2, we'll get 27, which is on our list. So I'll do third root of 27 times third root of 2. And then minus for 16, it looks like 8's going to work. So third root of 8 times third root of 2. Okay, and now we all have these third root of 2 in the end. Okay, so cleaning it up, third root of 125 is 5. Third root of 2 plus cube root of 27 is 3. Third root of 2. And cube root of 8 is 2. So you have 3 third root of 2. Sorry, 2 third root of 2. Okay, now just go left to right again. So add those together. That's 8 third root of 2 minus 2 would be 6 third root of 2. That's what this one cleans up to be. Okay, and that's pretty much it, right? So sometimes you could be able to add or subtract right away. This one we had to break it apart a little bit first before we were able to combine it. All right, little bonus math, right? It's your lucky day. Since this was kind of a short lesson, I want to give you a preview of what's coming next. So today we added and subtracted with these little binomial expressions. Tomorrow we're going to start multiplying these little binomial things together. All right, and just a preview of that, it's basically going to be, you could probably guess, right? If I were to say I'll give you $50 to guess what you do here, hopefully you would guess FOIL, right? And so all we got to do is know how to multiply the stuff together. So 4 times 5, and then 4 times 4 radical 2 becomes 16 radical 2. 2 radical 2 times 5 will be 10 radical 2. And then the back two are the goofiest, but I got to do 2 radical 2 times 4 radical 2. I can multiply the 2 and 4 to get 8. And then the radical 2 is radical 4. Oh, but that's fantastic because radical 4 is just 2. And 8 times 2 is 16. So in the back we get 16. And now we just combine our like terms. 16 and 20 make 36. And 16 radical 2 plus 10 radical 2 is 26 radical 2. All right, so that's what's coming next, is to multiply with these binomial expressions. That's a little bonus math, right? You don't even have to pay anything extra. It's just free bonus preview. Yeah, so that is it. Thank you for watching. Actually, I forgot one part. This picture was in these slides when I got them from another teacher at one point. And I'm trying to figure out like what is going on in this picture, right? Like I really don't understand it. Like first of all, the kid is tiny, or the pencil is huge, one of the two. I believe this is German, but he is pole vaulting over it because it's so easy. So I thought this lesson was kind of easy. So maybe it's like it's just pole vaulting over some German math book here. I have really no idea, but it's quite the picture. I've thunk about it for many hours trying to figure out what's going on. But all right, sorry, that's all. Have a good day.